Hi, everyone.
Hello.
Hi. Hi, Thomas. Yeah. So turn on your videos, and yeah, you can keep you unmuted also. Yeah. Okay, great. I think that there are 13 students, and actually some students cannot attend today's lecture. At least I got the 2 messages. Yep. So, yep. So I'm Kaz Shinki, the instructor of this course. I'm a statistician, so I have a PhD in statistics from University of Wisconsin-Madison. And before I got a statistics PhD, I worked for the Bank of Japan, and I did some macroeconomic analysis for about 4 years. So I'm on the applied side, statistician in some way. So yeah, so I put today's items in a chat. So I cover at first the syllabus first, then after that I want to make a survey about your background, especially your background in our language and the statistics. And I hope to have 1 or 2 breakout room sessions to just have you interact each other. And after that, I do chapter 1. Chapter 1 is just an overview of the course. And then after that, possibly we do the chapter 2 or R, if some of you haven't studied it before. Okay, so at first, I want to explain the syllabus. So maybe I will share the screen. And yeah, syllabus is available in Canvas, so you can download it as you want. But I want to make sure that everyone is on the same page. Okay, so Stat 5820, Introduction to Data Science. Course number here, and the instructor is the Kaz Shinki, and the email is this one. I usually use the Gmail. But you can use either this mail or this mail. All mails are forwarded to the same account. That is Seiki Bunpu, means the normal distribution in Japanese. And the course website, we use the Canvas, and the lecture, the Tuesday, Thursday, 6:30 to 7:45 in Zoom, and online, the synchronous throughout the semester. And office hours, the Monday, Wednesday, 5:30 to 6 p.m. in Zoom only.
Lectures on Monday, Wednesday, or the lectures on Tuesday, Thursday?
Oh, sorry, the Monday, Wednesday, sorry, I think the typo. Monday, Wednesday, 6:30 to the 7:45. And the office hours, the Monday, Wednesday, 5:30 to 6 p.m. So just 30 minutes before the lecture. And also the office hours on Tuesday and Thursday, the 2:45 to 3:30. And this Tuesday, Thursday office hours are both the in-person and in Zoom. So I opened the Zoom session in my office. And generally, I don't recommend you to come on Tuesday. I mean, it's fine, but the Tuesdays, another class has a quiz, so probably there are more students there. So if you have more time to discuss with me, then I recommend to use Monday, Wednesday, or Thursday. Tuesday, it's fine, especially if you have just a short question. That's fine, but I recommend the other days. But of course, it's fine to come. And prerequisites, the Stat 5030 or Stat 5800. So 5030 is the statistical computing and data analysis. Stat 5800 is the introduction to mathematical statistics. And at first, I would like to make a survey on this one. So at first, if you have taken 5030 or not, and also 5800 or not. So I launch first survey. So you can answer whether or not you are taking, you have taken or you haven't taken, or you are taking the 5030. I think how many students here are? Maybe 11? Yep. 6118. So I think 3 more. 9, 2 more, I think.
Oh, it closed out for me.
Sorry?
Oh,
Have you?
the survey closed out for me.
Oh, okay. So you cannot answer.
But I did take it, yeah.
Did you take it? Okay. So maybe another person, maybe we have 11 students here. So maybe one more still. No? Okay, so maybe that's it. Okay, so you have the okay, 2. Okay, so who haven't taken the 5030, can you answer if you haven't taken 5030? Who did not take 5030? I just want to know that what kind of the computer skills you have. So if you answered no,
I didn't take it.
okay. So what's your name? Sorry, I can.
Tom.
Thomas.
Yeah.
Oh, Thomas Chin.
Yeah, Quinn. Yep, Quinn.
Oh, okay. So you are fine. Okay,
Yeah.
okay, that's fine. Okay, and another student who answered no. Anyone? Maybe.
Sorry,
You?
I said no.
Oh, you said no, but you have taken, right?
Well, not 50-30. I've had plenty of other practice with this. This isn't scary. You know me. I was in your
Yeah, I know you.
50-70 class.
I think you have taken the course, right?
Plenty of stats. I'm not worrying about that.
Okay, yeah. Okay, so you.
Oh no,
our
this is the
language.
one we just did. Sorry, was
Yeah, you did, right? Okay, yeah, and
okay.
and the one is taking, but I think that's fine. So okay, so then probably we will just skip how to use R or something. Maybe I introduce briefly. That's it. Okay, so so next there, Paul. Sorry. Yep. So sorry, maybe I should have shared the result. Yeah, so 7-1. So basically, the 2 people answered no, and 1 people is 2 people answered no, but actually the both of you have experience in R. Okay, so next question. Sorry. Yep. And next question: have you ever taken 5800 or not? I will launch the survey. Yes, you can answer. 1, 2, 3, 4, 5. Okay, so 4, 2, 3, 4, 4, yeah, 4, 4, 3. So maybe half and half. So 3 people are taking the class, and I think that class is just before this class, right? So the 20 minutes before. Okay, so I see. And actually, the stat 5820 doesn't use much material from 5800, but at least we have estimation in the testing, so the knowledge will be useful. Yeah, so this is the result. Okay. So 5800 is more theoretical class, and this class is the most applied oriented class. So okay, so next one, I would like to know your background in the area. So mathematics, statistics, or computer science, or other engineering, or natural science, such as physics, chemistry, or social science, such as economics, or others, maybe education. Oh, mathematics, mostly mathematics. Okay, so natural science, 1. That's it. Maybe one more. No. Maybe some trouble. Yes.
I didn't answer because my major is not either of the options.
Oh, okay. But the others is another thing. So I thought it's. So what's your major?
My major is psychology.
Psychology. Yeah, psychology is heavy in statistics. So yeah, I understand that. And the one person said natural science. What's your major?
I'm biophysics.
Oh, biophysics. Okay, I see. Yeah, so biology is also heavy in statistics. I see. So yeah, this time the mostly mathematics and statistics. In typical years, maybe some industrial or engineering students. Okay. And the last question. This is almost just for my purpose, but some of your undergraduate students and some are minor in statistics, maybe major in mathematics or some other area, and minor in statistics, 2 people. Okay, I see. 2 and 8. Maybe one more. Okay, 3. So 3 people. Okay, I see. So minor in statistics, but I heard that the major is either mathematics or statistics. So anyway, so you are in the mathematics department mostly. Maybe 1 or 2 person are not, but yeah, I see. So the one reason that we offer this course online is that the mathematics department tries to offer all required courses in minor in statistics online, so that it's convenient for you to take the courses. Okay, thank you. So 3. Okay, so that's it for the survey. So I would like to continue the syllabus. Okay, so I think you are seeing syllabus. Yeah, so the Stat 5030 is more closely related to this course material, but I think that all of you are fine at this point. And yeah, but still, you can forget the materials the course covered. So you can review the chapters 1 to 6 and 11 and 13 of Stat 5030 slides as needed. Yeah, and overlap with other courses. This course is basically the same course as Math 5890 offered in winter 2019 and winter 2020. So if you have taken this course before, then don't take it. Okay. So I think it's probably no students are there. Maybe possibly Thomas, have you taken this course? No. Maybe not.
No.
No, okay, then that's fine. Yeah, it's pretty old course. So yeah, so just the course was renamed. And also if you are taking or have taken DSA 6000, that course is also similar to this course. So consult with your advisor if you plan to count both courses for graduation. DSA 6100 is also similar. I think that probably 6000 and 6100 combined covers slightly more materials than this single course. Yeah, and the lectures, attend all lectures and turn on your videos unless special reasons. So if you have some reasons that you cannot attend, that's fine. But otherwise, attend all lectures. Yeah, and active participation is much appreciated. So you can ask questions at any time. And this is the lecture link, and the lecture videos will be uploaded to my YouTube channel. And office hours, we have different links for Monday, Wednesday, and Tuesday, Thursday. So just use the correct link. Textbook Introduction to Statistical Learning and Application in R, the second edition. So this is downloadable at the official website. So, but still, the printed version may be easier to read. But anyway, so it's available. The printed version isn't very expensive, and we are using the second edition. I haven't seen exactly the difference, but the biggest difference is the neural network. So second edition includes neural network, and the first edition does not. So that's the difference. And if we have sufficient time, that we will cover some neural network. Last year, just I gave a preview of the neural network, not really covered it deeply. And the computer environment, the course requires a computer with R language and R Studio installed. So download R and R Studio into your computer at your earliest convenience. Probably you have already had R and R Studio. Have you used R Studio before? Especially, maybe I should have poll, but okay. So raise your hand if you have used the R Studio. Okay, so maybe some of you are not. Okay, I don't know. The Shaoli is using R Studio also. Not really. Have you? Maybe some of you have taken 5030 with Shaoli Kon, Professor Shaoli Kon.
I did. She did.
She did. Okay, great. So the R Studio, I think it's not essential to use anyway. So that's our language, but to submit homework, usually I require the R Studio format because the grading for this course is pretty challenging. So that I would like all of you to follow the exact format. Yeah, and course outline. So this is a 3-credit course. 3-credit course about the applied statistical learning and designed for upper level undergraduate students and graduate students in mathematics and other quantitative fields. And so we cover the traditional models such as linear regression and logistic regression. And after that, we cover the more advanced statistical materials. Yeah, so basically I developed this course because, these days we need more statistical modeling. So when I worked for the industry 20 years ago, maybe the 5030 materials are sufficient to start with start as an, entry-level statistician. But now that we need more advanced models, so that's why I created this course. So topics includes the bias variance trade-off, regression, classification, and cross-validation, bootstrap, model selection, regularization, splines, generalized additive models, tree-based methods, support vector machines, principal component analysis, clustering, and as time permits, neural network. And the course consists of 3 components: the theory, computing, and data analysis. Yeah, so I will explain it later in chapter 1 in more detail. Yeah, so we use R and R Studio as the primary tool for analysis. And we have the final projects in the same way as Stat 5030 and other applied statistics courses. So I heard from Shaoli that she didn't have enough time to have in-class presentations. So students submit the presentation video. But this semester, I ask you to share your screen and make a presentation, probably 12 minutes presentation. Yeah, learning outcomes. So this is very practical course. So after taking this course, you will be able to understand concepts and mathematical foundation of statistical learning models, and use the R language to apply the statistical learning models and choose and implement the appropriate models for real-world data analysis problems.
I think you might be muted, Professor.
Yeah, sorry. The quizzes and homework. So quizzes every time. So Monday lecture. So the quizzes are due on the Wednesday or Thursday. And Wednesday's class, the quiz is due on probably Monday. Wednesday, yeah, probably Monday. Yeah. And homework will be assigned only a few times a semester, probably twice or 3 times. So yes. And the midterm exam, so one take-home exam. So usually the data analysis questions and also some algorithm questions. And problem will be given 1 week prior to the exam. And the final project, the final exam is, we don't have any final exam, so it's replaced by final projects. So implement a data analysis project using R on real data of your choice, and then make your 12 minutes presentation in Zoom. And the last 2 days of lecture, as well as the final exam period, that we have the final presentations. So attend all presentations. So you will make presentation on you will make a presentation on either of these 3 days, but attend all presentations. Yeah. And the presentation schedule will be decided after the midterm. And the project plan is due on March 31st. So project plan is a 1 to 2 page summary of your data and analysis plan. Yeah, so I will give more detailed instruction before the project plan due date. And the grading is based on the quiz and homework and the midterm and the final project plan and the final project. Yeah, so final project plan is important to be successful in the final project. So until last semester, I didn't give any points for the final project plan because that is just a plan. But sometimes the students they could not understand this is very important. So this time, the 3% credits for that. And the presentation replaces the final exam. So if you don't appear in the presentation, your presentation, then you will not get credits, course credits. Yeah, and this grading scale is guaranteed. So that means if you take, for example, 81 as a weighted score, then you are guaranteed to get an A. If your score is 79.5, you may be A minus, but if you are lucky, you will get an A. And the score for the final project is a little bit special. So basically, the only outstanding presentations get more than 80 points. So 90 to 100 points, but that is up to only 35% of projects. And a good presentation will get 80 points. And in the past, a vast majority of projects get 80. And the good presentations with some weakness will get 60 to 79. Presentations with serious weakness will get 0 to 59. And important dates, the take-home exam midterm due February 24th. So that means I will give exam 1 week before. And final project plan due and final presentations. And final presentations on the last day, just make sure that you are available from 6:30 to 8:45. Hopefully we will finish earlier, but it depends on how many students are in the class. Do you have any schedule conflicts after 7:45 on May 1st on Monday? I think 6:30 to 7:45 is, designated exam time, but just I want to make sure, just for this day. So are you fine with that? Okay, great. Yeah, so just make sure you are available on these dates. And references, this is basically references for the R language and also statistical analysis using R language. Yeah. Okay, so that's it for the syllabus. Do you have any questions? Any questions on the exams or?
Not at this time.
Sorry. Hello?
Not at this time. I'm good.
Oh, you're good? Okay, great. Okay, so maybe we finished the survey and the syllabus, so maybe we make some break up rooms and you can introduce yourself, each other for maybe 4 minutes. So I think I have to make breakout rooms, assign automatically, maybe 3 breakout rooms. Yeah, create. Yeah, so maybe 4 minutes, maybe 4 to 5 minutes to introduce or just chat each other. Okay, so let's start. Hi. Oh, hi, Hunter.
Hello. Yeah.
Yeah. So now I set up. Can you join the room 3?
Room 3. Let's see.
Is it possible? Oh, maybe assign. I have to assign room 3. Yes, I
there we
assigned
go.
it.
Yeah, I see the
Yeah,
option. Okay, I'll see you
Yeah,
later.
you can introduce yourself. Yep.
Yep.
Hi. Yeah. So just wait for 30 minutes, 30 seconds. Okay. So will we have another session, or you are tired with breakout room? One more session? Any? Okay, maybe one more session. Okay, so maybe the slightly maybe yeah, 4 to 5 minutes. I don't know. I think that we recreate a sign automatically. Yes. Yeah. So enjoy conversation for 4 to 5 additional minutes. Okay, so now we start the class. So do you have any questions about the course, or any questions did you come up now? No. Okay, so yeah, you can ask any questions at any time. So now I will start the lecture. Yep. So chapter 1 slides and chapter 2 slides are available on the website, so you can review at any time. Yeah, so chapter 1 is introduction. So at first, this class is for data science. So the mathematics department offers several courses for probability and statistics, and maybe just 1 or 2 courses in data science. So what is probability? What is statistics? What is data science? Or what is machine learning? So what's the difference between those subjects? So that is the first topic I want to discuss. So at first, I start with what is the difference between probability and statistics. So often these 2 subjects are in the same course, and almost those 2 sound the similar subject. The difference is here. So I like this explanation best. So probability is to design a casino, so based on mathematical assumptions. And on the other hand, the statistics is to play in a casino based on data. So this is the words by Alexander Krostelev, the professor emeritus at Wayne State University. Maybe, I don't know, any of you have met him before? Maybe no, maybe Thomas, maybe met before, but yeah, so he retired a few years ago, but he is excellent to put everything in a simple, elegant way. Yeah, but still, the statistics is developed based on probability theory, so these 2 areas are closely related. So the difference between probabilists and statisticians is here. So one sample question. So what is the probability to get the head side up when you spin a penny? And when we see high school textbook, maybe in the first chapter in AP statistics textbook, then the probabilist answer is 50%, okay? Or we assume 50%. We assume that those, head and the tail are equal likely, so 50%. So typical way of statisticians thinking is here. So spin a penny 1,000 times. So if the head side appears 210 times, then the estimated probability is 210 over 1,000, so 21%. To be on the safe side, the standard error for this estimate of 21% is this square root of 0.5 times 0.5 divided by 1,000 by the property of some variance. So that is 1.6%. Then, based on the statistical theory, we can say that we are 95% confident that the head probability is between 21% plus minus 3.1%. So probabilists start with the mathematical assumption. So the probability to get the head side up, that is the assumption we have to make. So that is 50%. Maybe we can assume 30% or 70%, but at least that is the assumption, our assumption, the starting point of the probability theory. The statisticians, they think about this kind of question based on data. So we observe it first, then we make an inference. And in fact, actually, the probability of head is around 20%. The source is here. So some physicists did a research on what's the percentage of head and the tail. The head and the tail are distinguishable. That is, at least different. So we have no guarantee that the 2 probabilities are the same. the dice are different. So dice are made so that the all faces are equal likely. So that's why the all faces are almost 1/6 probability, but the coins are different. And especially if we spin a penny, it spins probably maybe hundreds of times. So if one side is slightly heavier, then probability is much different. Okay, so now that we have seen what's the difference in probability and statistics, then what is data science? So data science sounds very similar thing to statistics, and I don't really know what's the exact difference. But usually the data science is, the word data science is used to, to extract knowledge or insights from data. So, data analysis is, okay, so the sample mean is this and the sample variance is this, and the sample mean is significantly different from the zero because of this or something like that. But the data science is to extract knowledge or insights. So more business oriented or engineering oriented area. And the data science is perceived as a combination of 3 components. So one is mathematical statistical modeling of data. And the second part is computer implementation of the models. And the third part is data analysis and implication to the real world problems. Yeah, so often if you only study mathematics, then we can only go from this one to second one to the last one. Okay, but usually the data science is motivated by the data analysis and the implication. So sometimes it's good to ignore all mathematical structures and they just focus on the objectives. Then it's easier to understand ideas. Yeah. So deductive argument is sometimes, too long to, reach the implication of the data analysis. So most statistical ideas and the data science ideas are from the real data analysis. So just be flexible to think about what's the idea behind the, data science, the models in data science. Yeah, and also we have the word machine learning. So machine learning, for example, the artificial intelligence, the models used in artificial intelligence are called the machine learning models. So machine learning is also similar to statistics or data science, but the machine learning is kind of a branch of mathematical and statistical modeling of the data, and it emphasizes the automatic detection of pattern and also the forecasting performance. So for example, a few years ago, I think 3 or 4 years ago, I worked for the Kaggle competition, data competition, and I tried to automatically detect the best model from the, for the data. And I discussed some methods to apply. And I worked with that project with another statistician, the Abhijit Mandal. He's a statistician and he left Wayne State a few years ago. But he said that okay, before you analyze that, before you evaluate forecasting performance, we have to see the scatter plot. We have to see the significance of coefficients. What's the underlying structure and what's the meaning of the models. Okay, so that's true in statistical context, but in machine learning contexts, people are interested in more in the automatic detection, automatic procedures, algorithms behind the data analysis. So the emphasis is different between statistics and machine learning. Yeah, so you can study both in mathematics department. So sometimes, we need statistical modeling and the interpretation is important. And sometimes more, the automatic detection of pattern is important. So example, so based on 1,000 handwritten characters, they build a model for the character recognition algorithm. So this is a typical machine learning problem, right? So suppose that we have maybe 24 by 24 pixel images. And okay, so we want to interpret some specific cell, pixel. And we want to interpret the quotient of that pixel. Probably that doesn't make much sense because the only important thing is the precision of the prediction model. So this is a typical machine learning problem. So this is different from, for example, models in economics. Okay, for example, unemployment rate, whether unemployment rate matters for the inflation. So we have two specific variables which have a lot of contexts, and the significance of the quotient is very important in economics, for example. But the machine learning model is the more towards automatic detection of the pattern. Yeah, and the statistical learning, this is included. I mean, the statistical learning is the part of the title of our textbook, so Introduction to Statistical Learning. But the statistical learning is mostly the same as machine learning, and it's not a common word besides this textbook's title. So maybe we can say that most machine learning models have a statistical foundation. So the word can be interpreted as machine learning with emphasis on statistical justification. So these are the just overview of probability statistics, data science, and machine learning. Do you have any questions or any comments?
This is Bill. I'll turn on my.
Sure.
I've had a lot of background practice on core on data analysis. To be honest, when you're going through this in the real world or engineering world that I do, most of the stuff that I do ends up the almost immediate assumption is it's normal. With very
Okay.
that's the very first thing. Pretty much everything's normal. And we have two situations when we do testing of durability or validation or confidence building. We can do one thing, and then we have a kind of an inverse problem where we physically do the same thing, but when we're talking about setting up tolerances or the specifications for different parts, because of stack, we actually use a Monte Carlo process that actually allows us to take a look at theoretically over a period of time, assuming our installations and our machines are cut the way we expect or build parts the way we to establish what the build and how it would distort over during assembly, which is also fascinating. So I'm used to doing number 3, the third part, without really worrying about everything else, or at least using assumptions. It's cool stuff. Thank you.
Yeah, sure. So maybe the more statistical way of thinking. So we have to check the normality. Then after that, we apply the model. So that is statistician's attitude, right? And machine learning, the engineer's attitude or a data scientist attitude is, okay, so we don't really care about the underlying assumption. Just apply the model and see how it works. Okay. And maybe assuming everything is normal is in between, right? So you care about the distribution, the underlying distribution, but you don't really check the distribution. So some people are just in between the areas. Yeah, that's interesting. Yep. Any other comments, questions? Okay, so the prerequisites, maybe this is informative slide. So data science requires variety of knowledge and ideas: mathematics, probability, statistics, machine learning, algorithm, computer implementation, data analysis, and domain knowledge. Okay, so mathematicians always start with this and the go this direction, right? So it's really hard to reach the data analysis or domain knowledge. So personally, I studied mathematics first, and after that, I joined the bank. Then just I do data analysis, and I focus more on the financial knowledge. Then after that, I studied the in-between statistics. Then maybe after I got a job at Wayne State, maybe I realized that I have to do more machine learning or computer implementation. So yeah, so I think it's hard if if you think you have to start with mathematics, then probably you have trouble to understand all ideas. So these are different ideas. These subjects have different ideas. Then you have to go both ways. From mathematics, logically you construct everything from mathematics, and also you have to think about the other way around. So you start with the domain knowledge, then you do data analysis, then after that you realize how to implement this data analysis and what's the theory behind that implementation and so on. Yeah, so the calculus, linear algebra, probability theory, so these are the mathematics. And statistics are based on probability theory. Machine learning is based on statistics in some way. And then after that, we do computer implementation, then data analysis. And the 5820 covers around here. So statistics and machine learning, and also computer implementation and the data analysis. 5800 here and 5030 here. So we have more overlap with 5030. Yeah. Any comments so far? Okay, so the next one is this is especially important for engineers. Maybe not many engineers here in this course, but in statistics, data are perceived as a realization of random variables. So this is different from some other fields, such as computer science or engineering. Engineering, people see data as numbers, but the statisticians see data are a realization of random variables. So here's one typical example. So how is one's academic ability determined? I read a book, and they decompose the academic ability into gene factors and environmental factors. So your academic ability is determined by, for example, 75% by genes and 25% by environment for mathematical subjects, for example. But that sounds strange for statisticians, because they assume that everything comes from genes and the environment, and we assume that everything is explained by these factors. So statisticians usually think in this way. So ability is decomposed into gene factors and environmental factors, but some factors are not explained. Maybe this error is pretty large. So, for example, physicists think about ability is decomposed into gene factors and environmental factors. So by definition, no other factors can come in. But in reality, so gene factors are explained by maybe parents' intelligent quality or something, and the environmental factors maybe where they live, or the how many hours that they studied or something like that. So only very limited information is obtained to express the gene factors and the environmental factors. So we should have the large error terms. So the error may be ultimately explained by genes and the environment, but it is reasonable to assume that there is an uncertain component, since we don't have all information on genes and environment. So this is the difference between statistical way of thinking and usual physical way of thinking. So we have error term. Yeah. And yeah, so that's the thing that I wanted to explain. And then now that we go to supervised and unsupervised learning, and I think I have to log into the session by another computer, and I have to write something. Do you have any questions so far? So I want to share the screen from my iPad. Yeah, I totally forgot that I have to use iPad. Yeah, just 1 minute. I have to import. Yeah, so we have the supervised problem and unsupervised problems, and also the semi-supervised problems in some cases. And at first, I want to explain the supervised learning. Supervised learning is a modeling problem when a response variable called label is available for the data, or supervisor is available for the data set. So this is the answer is known for the sample data. So for example, estimating a formula for height of students given the weight of students. So we have the, weight and height. And we want to explain the height by weight. But we know weight and height of each student for 100 observations. And our problem is how to determine this curve. Maybe this is the trend line. We want to estimate this. So this is the regression problem. So we are interested in explaining height by weight. For example, we have one observation with weight, but the height is unknown, and how to forecast height. And then we can see that this is the estimated height, but for training data set, that we know that the given data set, we know both the weight and height in the data set. So this is so-called a supervised problem. And this is typical regression problem. So to determine this red curve is a regression problem. And another example of supervised learning. So example 2, to establish a criterion to distinguish the 3 species of flowers when characteristics such as color, height, diameter are given. So in this case, the problem is called classification. So suppose that for simplicity, that we only have the 2 factors, the maybe height and the diameter, height of the flower and the diameter of the flower. And we have 3 species, maybe species 1 we have here. But species 2 have different characteristics, so observations are around here. And species 3 we have around here. Maybe somewhere a little bit harder to distinguish because maybe 2 and 3 are like this. But still, it's clear that which flower is in species 1 and which flower in species 2 belongs to species 2 and species 3. Maybe that we need some criterion like this to distinguish the 1, 2, and 3. So this is a typical classification problem. And in 5030 or many other statistics courses, the only supervised learning has been covered. And another type of analysis is unsupervised learning. So this is a modeling problem when a label is not available for the dataset. So that is the answer is unknown for the sample data. So this is a little bit more abstract situation, like you are a newborn baby. So you don't know what is apple. Okay, so what is apple? Then, if you are an adult, then you can get some explanation, right? So apple is a fruit which is red and something like that. But if the children don't know any words, then you cannot really get the answer. So that kind of situation. So it's more difficult situation in some sense. So one example of unsupervised learning is this. So developing a business cycle indicator when 30 economic time series data, such as monthly unemployment rate and monthly industrial production, are available. So that is dimension reduction problem. So the situation is like this. So we have unemployment rate. Unemployment rate is higher in recession, lower in expansion, maybe higher in recession. So this is time, and the y-axis is unemployment rate. Okay. And the second one is what? Monthly industrial production, IP. And if economy is in recession, the lower production, and many people are unemployed, and only small part of the labor force is actually they're producing something. So almost the the opposite thing. So industrial production is lower when unemployment rate is higher, and industrial production like this and lower. Okay, but it's not exactly the opposite. So it's almost opposite, but the pattern is slightly different. And maybe another indicator, maybe price index, CPI. Inflation is higher when economy is booming. So that means economy is booming, industrial production is higher, but inflation is also higher. Also, unemployment rate is lower. That means the employees have more power to negotiate the pay. So the inflation rate or the wage inflation is higher. So that means probably that this is similar to industrial production, but maybe a little stickier price, like maybe like this. So it's similar to this, but slightly different. Then we want to make some business cycle indicator. We want to materialize the concept of expansion and recession. Then if we take the weighted average of something, maybe if this is x1, x2, and x3, maybe we calculate the x1 minus the 1.5 times x2 plus maybe the 2 times x3 or something like that, then we have more smooth business cycle indicator we can make. Okay. So making this series from original, the 3 series. So this is a kind of dimension reduction problem. So this is the 3-dimensional data, but finally we get 1-dimensional data indexed by time point. yeah. Sorry, can you hear me?
Yes, I can.
Yes.
Oh, okay.
Yeah.
Sorry. Yeah, I think I was confused
Yes.
by some features. Yeah, sorry. Yeah. Okay, so that's the one example of unsupervised learning, and the example 2 of unsupervised learning: establish a criterion to distinguish the 3 species of flowers when characteristics are given, but species of them are not available. So this is similar to the classification problem before, but actually it's much more difficult because we have 2 variables, maybe height and diameter here. And we have the species 1. And we have species 2. And we have, sorry, this is not classification, species 3. But we don't know which observations belongs to species 1 and species 2 or species 3. But you can see that we have 3 clusters. Maybe we have this cluster, and this cluster. So even if we don't know the label, which one is in species 1, we can probably distinguish these 3, and probably the boundary is here, something like that. So this is called clustering. So this is unsupervised problem because we don't have the label. So if species 1, 2, 3 have names, of course, we cannot identify it, but based on data, at least we can divide this into 3 different categories. Yep. Do you have any questions about the difference between supervised and unsupervised learning?
Yeah, so in this in this example that we have on the screen right now, if this were supervised, then a good performance metric for our model would be the accuracy, right? But because it's unsupervised, do you know of any good performance metrics that we could use specifically in the context of this being unsupervised, where we don't have the labels of the 3 flowers?
Yeah, that's a good question. And generally, we don't have any criterion. Yeah. Generally, we don't have any criterion. We need some external. We need some external variable to evaluate it. Yeah. But if we have external variable, then it's already supervised. So it's a little bit hard. But maybe some smoothness of the curve, that kind of thing can be one kind of the partial criterion. But generally, we don't really have measure for unsupervised data. Yeah.
Gotcha. Thank you.
Yeah. I think it's a little bit hard. Yeah. So usually for this context, the business cycle context, maybe we want to predict the total production, the gross domestic production, or something like that. So we need some ultimate objectives, but but actually no, because that's right. Yeah, so it's a little bit hard. Of course, in algorithm we have to optimize something. That's true. So we need some underlying assumption that suppose that these 3 clusters come from the bivariate normal distribution. And we have some variance assumptions on the variance and the covariances. Then based on that assumption, what's the maximum likelihood we can achieve or something like that. But so we have some criterion to determine the algorithm, but we don't have the very clear objective function for different from supervised learning. And the other thing is the semi-supervised learning. So semi-supervised learning is a modeling problem when a label is available for a part of sample data. So it's in between the supervised learning and unsupervised learning. So one example, the developing a translation algorithm from English to Chinese. Probably this is the biggest topic, in machine learning in the next decade, maybe. But usually the side-by-side translation is available for only limited number of documents, say 1,000 documents. But the 10,000 documents are available only in English. So we have so English and Chinese. Okay, so I don't really know Chinese language, so I cannot really write examples, but suppose we have A and B and B, C and C. So we have this data, so we know the correspondence between these. But for the others, maybe D, E up to Z, we only have this. Then we want to identify the pattern. So maybe think about the newborn babies. So newborn babies, they don't, compare English and Chinese language except for special circumstances. So we don't have this part. Okay, so we only have this English part. But still, kids can learn language. So probably even this partial information isn't necessary to understand these documents. Right? But that is particularly hard. So if we have even limited information, this corresponds to this corresponds to this, and this corresponds to this, then it's easier to get the translation. So for here, so what should be the D, E, F up to Z? Yeah. So even if we don't have any link, suppose that we don't have any link, English is developed somewhat logically in some sense, and Chinese independently developed, but in a logical way. And both describe the same world. So basically, without any connection, probably we can identify the meaning of this document, and we can ultimately identify what's the corresponding concept here. Right? Yeah. But that is particularly difficult. So if we have partial information, we want to use it. Okay, but still, this information D to Z should be useful to evaluate what this document means. For example, I don't know, but several important words. If it describes the nature, for example, like we have the sun or earth or something like that. So we have several important quantities, important words. And if we see the frequency of words or relationship between words, then probably we can identify these terms from the documents, right? But that takes a long way. So even if we have partial information, that should be useful. But this unsupervised part that should be useful also. So this is unsupervised learning example. Also, practically, many of the data set is actually unsupervised. For example, character recognition problem. So maybe some people they read some handwritten characters. So we have maybe 10,000 the characters read by human, but we have the 1 million characters which are not read by a human. Then we have to predict that so what each letter means. So yeah, so that is actually the unsupervised learning. And also the data science competition, usually we have training data set and the test data set. But in this context, we can see that this part is training data set. And the other part is test data set. So still that we can see it as semi-supervised learning methods. Yeah, we don't cover this because this is very complicated, but just I would like to discuss the concept. Oh, sorry, it's already exceeded the time limit. So we cover the remaining part of chapter 1 next time. Sorry. So if you don't have any questions, let's see you on Wednesday.
I've got a question real quick, Professor.
Sure. Yeah.
So when we're talking about the response variable being known or unknown in supervised versus unsupervised learning, is it known? So could you have an example in unsupervised learning where the human implementing the model knows the answer, but the model itself doesn't? Would that still be an example of unsupervised learning?
Yeah, I think that that depends on the framework, but probably that is unsupervised learning, mathematically speaking. So you only have the implicit information people have, right?
Mm-hmm.
Yeah. So that is the typical unsupervised learning. Yes, like the business cycle. So people have some idea of business cycle, but we don't have the exact definition of business cycle. So yeah, that is in the realm of unsupervised learning. Yeah.
Okay. All right. Thank you.
Sure. Okay. So if you don't have any questions, so see you on Wednesday.
You mentioned earlier that you did a Kaggle competition with a statistician. I'm just curious. Did you guys place high or no?
Sorry.
So you mentioned earlier in the lecture that you and the statistician had done
Kaggle
some
competition.
Kaggle competition.
Yeah.
Yeah, I was just wondering, like, just in general, maybe like how well do statisticians tend to place in Kaggle competition?
I don't know. I don't really know, but these days the programming skills are more important, right? So I think the statisticians are not that competitive, but it really depends on the person. Yeah.
All right.
Yeah, like for example, observe that the gender ratio of Kaggle competition, it's dominantly by male, right? What's the reason? Because the system engineers have, advantages. We have large data set and more flexible, algorithm. That is a key, right? Statisticians, the probably male and female, maybe 60% male, but not dominant. But the Kaggle competition dominant. That means, more system engineers work on Kaggle competition. So I think unfortunately, I think statisticians are not that competitive.
All right. Yeah, we'll see you guys. Thank you.
Okay, see you.